When you're given a question of solving a triangle, usually what you're given is you're given a few sides and some angles. And solving a triangle means you have to figure out all the sides that's not given, all the angles you're not given. And there's a convention in the naming of sides and angles. For angles, we use capital letters. And for sides, we use lowercase, but we use the same letter for the sides that's the opposite of a given angle. So since here's capital A, and this is the angle, and opposite to this angle, there's this side. This one will be called small a. Okay, then what would this side be called?
Small b.
Small b, right? So this should be b equals to 6. What about this side? C. Okay. And therefore, since small a, small b, and capital C are given, to solve this triangle, we have to find big A, big B, and small c. That's what we have to find. Okay, let's do this easier one first. How do you find C? Pythagorean theorem, right? So a squared plus b squared equals to c squared, which means that you have 11 squared plus 6 squared equal to c squared. And that's 36, 121, so c squared is 157, which means you have to take the square root of 157. And then I don't know, so I'll use my calculator.
12.5.
Yeah, 12.52 or 53. Okay, so that part is done. Now let's find angle B. How can we find angle B?
Well, we know the triangle itself equals 180 and 90 is given to us. So
Okay, so 90 is given to us. So if you add up all the angles inside of a triangle, they have to add up to 180, right? So we know that this plus this should be 90 degrees. Okay. But because we don't know angle A yet, we still have to figure out something else. But we will eventually use that. Okay. What else should we do? Any ideas? Yes?
You can do inverse of tan.
Yes, you can do inverse of tan. Because, see, you have two sides, 11 and 6. And with respect to angle B, 6 is at the opposite of angle B, and 11 is adjacent to angle B. And if you write down SOHCAHTOA, this is the only thing that has both opposite and adjacent involved, right? So we know that tangent of theta is equal to opposite over adjacent. Therefore, theta must be tangent inverse of 6 over 11. Let's see what that is. 28.61 degrees. And by the way, whenever you do this, make sure you're doing things in degrees. Okay? When it comes to practical questions, we like degrees over radians. And a lot of the calculators have two different modes, degree mode and radian mode. You have to figure out how to switch back and forth because there are some questions that you have to use radians for. Okay, so if you try this and you got a completely different answer, that's because your calculator is not in degree mode. Okay? You have to change it to degree mode. All right, so that's your angle B, by the way. And tangent of B is this. Now, how do you get A? Just as said earlier, you need to subtract. So these two angles are complementary, so you have to subtract from 90 degrees, 28.61 degrees, which gives you, what is it, 61.39 degrees. That's it. We've solved the triangle. We figured out all the remaining angles and sides. Okay, let me give you another example. Okay. So here we have now B as unknown. Right? How can we find B? Good. Pythagorean theorem again. 5 squared plus B squared should be the hypotenuse squared. Right? Pythagorean theorem says sum of the squares of two legs gives you the square of the hypotenuse. Therefore, b squared is equal to 81 minus 25, which is 6, and then 56. And you have to take the square root of 56. b equals to 7.483. 7.48. Okay. Now, what about angle b? How can we find angle b?
Cosine.
Right, this time it's cosine of angle b, because this is adjacent, this is hypotenuse. And among SOHCAHTOA, ka is the one that relates between angle A and the adjacent side A and the hypotenuse H. So you have 5 over 9. Therefore, B would be cosine inverse of 5 over 9. So we get 56.25 degrees. And once again, angle A is obtained by subtracting from 90 degrees, angle B. So that's going to be 33.75 degrees. I want to give you this last flavor, and then I'll give you some time to do the other examples. Okay, so this third one. So far, I've given you 2 lengths, and you have to find one other length and 2 angles, right? This time, it'll be like and then find all the lengths. And here, the easy part is this other angle, right? What's the angle A?
20.
20 degrees, right? Because it's 90 degrees minus 70 degrees, which is 20 degrees. Okay, but then, now, what do we do? How do we find this length, BC, which is A? Yeah?
Tan of 70.
Tangent of B, tangent of 70 degrees is 20 over A, right? Opposite over adjacent. So we are again using tangent equals to opposite over adjacent, and opposite is 20. A is right adjacent to this angle 70, so that's what you get. And you're trying to solve for A. We don't like fractions, so let's multiply A both sides. So you get A times tangent 70 equals to 20. And then you can divide by tangent 70 to get 20 divided by tangent 70. What's that? And then I'll multiply 20 to that. Okay, good. So if I do that, I get 7.279, which is 7.28. What about this angle, this length C? What should we do? Well, 20 is given, so we have to use that. And this is hypotenuse. So which one do we use? Sine. Sine has opposite and hypotenuse, right? So we say sine of what? Sine of 70 degrees is 20 over C. Yes?
Once you get 7.28, can you use Pythagorean theorem?
Oh, that's yeah, that's right. You can also do that. You can use Pythagorean theorem and say 20 squared plus 7.28 squared, and then take the square root. Yeah, I guess that might be easier, I think. But since we are already doing this, let's do this. Okay. By the way, that's not the only way. There's even a third way, which is to use cosine of 70 degrees as 20 over C. Right? Because here's 20, not 70, 20 degrees. Okay. So here's 20 degrees. Cosine of 20 degrees is adjacent over hypotenuse, so you still get that. So you have basically 3 different ways of getting it. You can use whichever seems most convenient to you. And we can multiply by C, so C times sine 70 degrees equals to 20, and then C is equal to 20 divided by sine 70 degrees. It's about 21.3. All right, so let's try this one. So first of all, what's the angle A?
27.
90 degrees minus 63 gives you 27 degrees. And then, how would you find length A?
Sine 63.
Right, sine 63 degrees. No. Here, A is adjacent to 63, right? So you should be using cosine. So cosine 63 gives you adjacent length, which is A, over the hypotenuse, which is 12. And then you can multiply 12 both sides to get A equals to 12 times cosine 63 degrees, and that will require a calculator. Make sure that gives you 5.45. How would you get B? Yeah, sine of 63 degrees would be B over 12. And again, if you multiply 12 both sides, you get B as sine 63 degrees times 12. So 63. I get B as 10.69. Okay, so that's how you solve this question.
Professor,
Yes?
after you find side A, when you have side A and hypotenuse, could you just use Pythagoras here?
Yes, you can also say, instead of using this, you can say B is square root of 12 squared minus 5.45 squared. And if you do that, you'll get the same answer. Okay, let me now give you some geometry problems. This is actually in the spirit of how the trigonometry was first used. So suppose you have a tall building and you were trying to figure out the height of this building. You don't know, and then one day it was a sunny day and there's a shadow on the side of the building, and you use a protractor to figure out that this angle is like 73 degrees, and you are about like 20 feet away from the building. Okay. And the question is, if you know that, then how high is the building? So that's the question. What should we use?
Tangent.
Yeah, we say tangent of 73 degrees is equal to
X.
y over 20. We decided to
Oh,
call this y,
sorry.
right? Multiply 20 both sides. So the building's about 65 feet. Here's another question, very similar in flavor, but since it's getting a little boring, let's make the question a little bit more exciting by imagine that this is a bank heist. So here's a bank. The entire building is bank, and you want to rob the bank, except that at night this is heavily guarded, there's no way to enter. So instead what you figure out is that there's among the buildings nearby, there's the taller building. So this one is 60 feet tall, whereas this one is 85 feet tall. And then you figure this out by, cities have their all building information, so you kind of figure out what the height of the buildings are. Okay? And then you're kind of far away. I drew this pretty close, but let's say these two buildings are a bit far away, and then your idea is that it's easy to get access to this building, so you're right here on the top of this building, right? And you're trying to have a zip line in between, and then you get into the other building and then rob the bank. Sounds like a plan, right? Okay, all right. Okay, so if that's the case, of course, you have to plan really carefully or else you get caught. So one of the things that you do is you go to that the top of this building, and then you have to measure this angle. Let's say this angle turns out to be 18 degrees. And given this information, the question is, what should be the length of our zip line? Okay, so if I call this X, this zip line. See, I see that Walmart has a few zip lines for sale, 100 feet ones. Can I use that one? Something like that. All right. So let's now try to solve this. How should we solve this? Any ideas?
You can get the length of one side.
Right. You first have to identify a right triangle because we've been just solving right triangles. Yes.
So, since the bank is 60 feet up, you just continue the line at the top, and that's where you get your right angle.
Right.
And that's 15 feet.
At 25.
Oh, 25.
25. Okay, good.
Then,
So you have this right triangle with 25. Okay.
and then you can get the
Because this is 18, this must be
That place will be 18.
72, right? And this should also be 18 degrees. So that's it. And here's this unknown x. That's what we have to figure out. Is that okay? Right. So at this point, we have two options. We can use cosine of 72, because 25 is adjacent to this angle, or we can use sine of 18 degrees, because 25 is opposite of this angle. Okay? And either one is valid. It doesn't matter which one you use. Okay, so I'll use cosine 72. Right. Where did I get 72 from? Because this entire angle is 90 degrees. 90 degrees minus 18 is 72. Right? So cosine of 72 is adjacent over hypotenuse. Adjacent to 72 angle is 25 divided by this x. And now we have to solve for x. Okay. What next? What should we do?
X equals 25 over cosine of 72.
Yeah, so we multiply x to this side, so x times cosine 72 degrees equals to 25, and then you divide, you get x equals to 25 divided by cosine of 72 degrees. Okay. And let's see what that gives us. Let's see. Okay, so that gives me 80.9 feet. Oh, so that's good. So if we buy 100 feet that's on sale in Walmart, we can execute this plan. Right? Yeah. All right.